Hi, for those of you that don't know me, my name is Jim Kleewein, and I'm a technical fellow in Office 365. I'd like to thank you for giving up about 30 minutes of your busy day to listen to me talk to you at Microsoft Research Summit 2021 about one of our most critical new science and technology needs, the need for privacy-preserving machine learning. To help set the stage here a little bit, let me describe the O365 business a little. O365 is a set of applications and corresponding cloud services. It includes popular applications like Word, Excel, PowerPoint, Outlook, OneNote, and their corresponding cloud services. The services that also support them include things like SharePoint Online, Exchange Online, and OneDrive. Our mission is to make people get more done in their jobs and in their personal lives. This is pretty cool. We make our money by helping people be more productive and to accomplish more of whatever they want to accomplish. It's a big business with hundreds of millions of users worldwide, processing billions of documents, meetings, and other forms of communication each day, and storing exabytes of data on behalf of tens of millions of businesses and organizations. It's used by individuals and families to communicate with family, friends, and others, school kids to learn, charitable organizations to conduct good work, small businesses to communicate and run their businesses, all the way up to the leaders of multinational corporations, local and regional governments, national governments, and even international organizations and governance bodies. Even today, helping people get more done involves lots of AI and ML to help them write better in the form of spelling and grammar checkers, to block nuisance and malicious communications with antivirus and anti-spam, to help them be more effective communicators with PowerPoint Designer, Presentation Coach, to help them find what they need through search and relevance rank capabilities, and a host of others. Having computers help people by doing tasks that computers can do frees up the people to do tasks computers can't do. Tasks like be more creative, find more insights, invent new solutions to problems, build better relationships, and find more points of common interest between people. That use of AI and ML will only continue to grow. And we need to be able to continue to deliver those AI and ML-powered productivity enhancements safely. That's where PPML comes in, enabling us to expand our use of AI and ML to help people do more, but to do it without compromising their privacy or the privacy of their data. So with that framing, let's get started. I'm going to start with a little bit of background that I hope isn't a surprise to anyone. It starts with the very simple premise that while we think the public internet is gigantic, in real terms it is, but it only contains just a tiny fraction of the world's data. Most of the world's data is not public. It's private. And it's private because the data controller has concerns about other people knowing that data. Let's talk about that concern for a little bit and some of the data that motivates it. Now, here's a list of a tiny subset of the private data used in almost any business. Data that's typically created, accessed, and stored in Office 365. Based on what you know about AI and ML today, if you were a C-level executive, would you want this data from your business used to train public models? Now, if you answered yes to that question, as an individual, would you be equally happy to have your chats with your spouse, your emails with your financial planner or your attorney used in public models, or any other sensitive document type that you have? You know, it's really surprising how many people, especially those who are not C-level execs, say they would accept the risk of a company's data being used to train those types of models. But as soon as it's their data that could get exposed through these models, they suddenly get more cautious. Now, why do you think that is? Well, with the consequences of a leak could be bad. They could be super bad. They include problems like identity theft, delisting from securities markets, mammoth lawsuits, and in some cases, maybe even assassination attempts. In a risk-reward trade-off, there's nowhere near enough reward for them to allow their data to be used to train a public model and to run that risk if the model could leak the data. That phrase, if the model can leak, really gets to the heart of the issue. Well, at least the heart of the issue we can solve with science and technology. The other is legal. We'll talk to that in a moment. Now, given the nature of the data we host, those emails, meetings, customer lists, financial documents, and the confidentiality of that data, we can honestly tell customers that our service is designed to not leak data. Outside of issues that aren't in our control, like someone accessing the service with your credentials or what happens with your data once it leaves our service, there are no known ways in which your data can leak. And if we find or learn of any, they're our highest priority bugs, and we'll inform you when that happens. It's simple. The message we tell is anything you give us, we'll keep safe. It's forthright. We'll be honest with you, and we'll tell you there might be bugs and factors outside of our control. We won't promise what we can't deliver, and it's transparent. We'll inform you if any data may have accidentally leaked. And above all, it's honest and truthful. It's what we do. It's who we are. We defend data entrusted to us. It's who our customers want and expect us to be. It's who legislators and regulators want us to be. Now, we know that models may leak data today. And because we know that, we can't continue to make that promise. The only promise we could make today is the service isn't designed to leak data except when your data is used to train ML models. And that's a pretty feeble promise. It's a pretty weak promise. We want to be able to use AI and ML and use customer data to train the AI ML and still make that strong promise that your data will not leak. So the remediations available to us today are very simple. Number one, we don't use data that's private to anybody. We only use public data. The pros of that remediation is it's totally safe. Now, the cons of that is it's super limiting because, as we started with, public data is tiny relative to the amount that's available privately. Our second option is to use a technology like federated learning, where we train a public model and then create per-user models from the public model so that the model, the data used by any given model for any given user is only the data that would otherwise be available to that user. Again, that's totally safe, but again, it's totally limiting because all we've done is add that user's corpus, which is a really small percentage of the total private data worldwide, to the already small private public data, so it doesn't really add to the pool of training data we want. Or number three, we can use techniques like differential privacy that decrease the probability of a leak, and then let the users decide if they're willing to accept the risk of the leak. You know, today that's the most promising approach, but it requires us to be able to understand, quantify, and explain to a non-technologist, like a lawyer, legislator, or regulator, what that level of risk is. If the amount of risk is low enough, it might not even merit letting them decide. The probability of a leak, after all, is never really zero in the real world. So we're not really looking for absolute zero. We're just looking for something close to it. Now, as we look at the technical issues with model leakage, there are several factors. Some of them, like memorization properties of models or model inversion attacks, are conceptually well understood, so I won't go into them. I will talk, however, briefly about a few of them that aren't as well understood. The first of those is retention and deletion policy. Retention's about keeping data you need to keep. For example, if you're being sued, you'd need to keep data relevant to the suit. For holding data a long time, ML's good. You don't have to worry about deleting it. But its twin, deletion policy, is a major problem. Deletion policy is about deleting data when it should be deleted, when it's no longer needed and shouldn't be retained. GDPR and users who choose to exercise their deletion data subject rights are an example of deletion policy that the EU mandates all technology companies that sell and work in the EU to meet. Additionally, contrary to popular opinion, most businesses don't want to hold on to their data forever. Data is not just an asset, data is a liability, and the longer you keep it, the worse that liability often becomes. Businesses want to keep data as long as necessary and no longer, and they establish deletion policies to do that, and they often have dedicated roles, a so-called records manager role, for people to define and to enforce that data deletion policy. And the problem with data deletion policies is that if the contents that are used to train the model can be exposed through things like the memorization property of models or model inversion attacks, so that from the model you can recreate some part of the training data, then the model acts as another copy of the data. And it exposes you to the risks of having not deleted it. It's like retaining it forever if they can recreate it with the memorization property. And that is a major problem for businesses. It's a major problem for Microsoft. If we don't honor European customers' GDPR delete data subject right requests, then we're in violation of European law and we can be subject to the fines associated with that. And for a company like Microsoft, if they levied the full fines against us that they could, that would be a fine of $6.7 billion, billion with a B. So we have to take deletion policy very seriously. When data is deleted, it must not be reproducible or recreatable from ML models. Another issue that's not always considered is when everyone in the business isn't allowed to see a piece of data, when the data is protected by a ACL, by a permission that says no, only certain people can see it. There's a few great examples of that, things like pre-release financial information. Up until the point that it's publicly released, pre-release financial information has to be kept strictly secret. Once it's released, anybody in the company can see it, but before release, only a very small number of people in the company can see it. Things like attorney-client privileged communications also fit that same pattern in order to continue to enjoy the legal protection of attorney-client privileged communications. Those communications have to be kept confidential between the attorney and the person seeking legal advice. If they could be leaked through some of these ML models and through these properties of those models, then you risk losing that protection for all of your privileged communication, which would be a disaster. Laws like HIPAA, SEC regulations also address variations of this need for confidentiality, need for privacy of data, even if it's used in training models. None of them say that the laws apply unless your data was used to train an ML model, then all bets are off. They say no, regardless of how it's used, you must maintain these properties. So those are some, but by no means all of the technology and scientific concerns. Now, I said there were legal ones as well. I'm not a lawyer, so I'm not really qualified to talk to those issues. But at the root of many of them is that AI and ML are relatively new. And there have not been any legal challenges or substantive legal challenges to what you're allowed to do and how you're allowed to treat data used in AI or ML models. What's a fair use of data and what's not? We can't predict how laws in court cases involving ML models are going to progress. But what we do know is the more we protect the privacy of people's data, the more we make sure that models can't leak and the model isn't a way to see the data that was used to train the model, the lower the probability we're going to be in violation of current or future laws or regulations at all. So, given that framing, which is pretty ominous, assassination attempts, loss of listing in public markets, mammoth lawsuits, why on earth do we even want to consider using private data to train ML models? Well, it's really about the data, and it's really about how much more data would be available to train models and how much better those models could get if we were to be able to use this private data to train them. So how much data are we talking about? How much, if we solved this, would we unlock for training AI and ML? And the answer is it's impossible to know. It's not public, so customers just don't publish how much they have. Nobody publishes how much they have. And in most cases, that's because they don't even know. And it's growing so fast that even if they told us today, it would be wrong tomorrow. What we can do is we can look at the total corpus size for O365, which is private data just for the subset of the world that's our customers. And if we compare it to the total size of the Bing index, which is public data for most of the world, O365 is several orders bigger, not factors, order. 3 to 4 orders bigger, depending on what you count. And that's just our customers and just what they store in O365. That's really strong suggestive evidence that private data is 3 to 5 orders bigger and likely more than that than public data. That much additional training data for AI and ML models is huge. If we just look at it graphically, that's saying the public training data, which is a big and powerful corpus, just like Satya Nadella is a big and powerful man. If we said the public data is about the same size as Satya Nadella, the same height, then the amount of data we would unlock by doing this is the equivalent of unlocking something at least as tall as the world's tallest building, the Burj Khalifa in Dubai, and it may be as tall as a piece of string dropped from the height of the International Space Station compared to Satya. That could unlock a lot of value for our customers and for AI and ML. So what characteristics do we need PPML, privacy-preserving machine learning, to have to be successful? Well, the first is obviously it's got to maintain privacy. That's obvious. PPML must be PP. Of course, by privacy, we mean in the strict sense of the word, not the common use sense of the word. Common use, it often means don't disclose directly or indirectly the identity of the person the data's about. That's clearly necessary, but it's not sufficient. What we need, using differential privacy terminology, is a value of epsilon that approaches epsilon. Now, that's a bit of a geek pun because it intermixes two different definitions of epsilon, but what it really means is the probability of sensitive data being revealed from the model, even with an infinite number of invocations, is very small, approaching zero. Second, it needs to be explainable, especially explainable to non-technical audiences, like users, like business leaders, like lawyers, legislators, regulators, and the popular press. They've got to be able to understand how and why it's safe. Intuitive explanations, consumable explanations by that audience are critical. Now, in many cases, these will be skeptical audiences, if not actively hostile audiences. They won't separate PP, privacy preserving, from other issues they have with ML. Now, obviously, we can't expect an explanation of why PPML is PP to address all of their concerns, but our explanations need to fit into the larger narrative about why machine learning is good and virtuous and safe for society to do. Thirdly, it needs to be provably privacy preserving. I said we've got to appeal to those non-technical audiences, but those non-technical audiences often hire highly technical advisors who share that skepticism or they share that hostility. So we need to be also able to prove to those audiences why this is privacy preserving. And finally, it needs to be debuggable. By that, I mean when it goes sideways, and it will go sideways, and we discover issues that made our PPML less PP than we had hoped, we've got to understand and debug why. We've got to learn how pervasive the problem is, learn its cause. Is it malicious use by an attacker or a blunder on our part? Was it an implementation error, or is it a fundamental error with the algorithms or science? And then, going back to the previous two requirements, we've got to explain why, and we've got to be able to prove it. To achieve PPML is a lot of work, and collectively, we need to invent a lot of new science and new technology to enable it. But if we do, the payoff is huge. The value of AI and ML, even only trained on public data, is literally already changing the world. Now, if we add 3 to 5 orders more data to that, what we could do with it almost boggles the imagination. That's why we've got to work together to guarantee ML is privacy preserving. Thank you for your time.